Right, welcome to the afternoon session of today's second day of the NEUROLIVE Symposium. The afternoon as a whole will sort of be more scientifically focused, and the first part of that afternoon session is dedicated to, to our co-investigators on the project. So, apart from Matthias and me, there's sort of Jamie Ward, who is a professor in computing and wearable sensing at Goldsmiths, Daniel Richardson, who's a professor in social psychology and now my colleague at UCL, and Jamie Forth, who's a senior lecturer, I think, lecturer in computing and computational arts at Goldsmiths. And so we found it really important to give some space to the perspectives and the research that happens, that is related to NEUROLIVE, but is also not the same as NEUROLIVE, and the sort of various specific expertises that, indisputable and completely necessary and invaluable experiences that you have brought to the project. And so this is sort of what we want to sort of dedicate this first afternoon session to. And I think the first speaker is going to be Jamie Ward. I hand over to you.
Well, thank you very much, Guido, and thank you all for coming to this presentation. My background is in wearable tech, computers on the body, and I'm going to speak a little bit about that. I promise you I won't give you any equations, but there may be one or two graphs. So, feel free to just close your eyes when the graphs are on, or not. Maybe challenge yourself. Actually, challenge me. Don't ask me any questions about the graphs, because I might not be able to answer them. Where I'm coming from is this was the dream of wearable computing about 30 years ago. This always-on, wearable, comfortable, body-worn personal assistant that you could give information to. It gives you information back, and you could go anywhere you want, and it unobtrusively helps you with your life. Well, that was the dream. Obviously, it didn't really work out like that. What ended up happening was you end up with a smartphone in your pocket that takes all your data, gives it to someone else, and then gives you little bits of it back whenever they feel that you might pay for something. So I want to caveat all of this by saying my vision of wearable tech is little brother that looks out for you, not big brother stealing all your data and trying to do things with it. Obviously, we know where it's gone since then. But I'll step a little bit into the past. When I first got involved with wearables, what we were trying to do is, could we build something that you put on your body that helps you? And the classic case is, could you have a wearable that detects when you're going to have a heart attack and then saves your life? Can it use your body signals that they can detect in a hospital on a wrist-worn device, and then interrupt you when it says, by the way, you're about to die, go and speak to a doctor. Now that motivation was all very well and good, and we tried to figure out, how could we do it using very simple sensors? So this was a few years ago, so it's like we didn't have all this deep learning and whatnot. Now we knew that if you looked at the electrical signal of your heart, it could give you an electrocardiogram, an ECG, which you could just about obtain in a wearable device, which we built there. But there's a problem with that. It's not enough to know what your heart's doing. You also need to know a little bit about what you're doing. Are you having a cup of coffee? Did you go for a run? Did you get in a fight with someone? All of these things factor in so that you can interpret the data better. So it meant that the problem isn't quite as simple as just recording a single sensor. And sometimes when we fear these sensors getting all this information about us, step back a little bit. There's only so much information it can actually genuinely get that's useful. Another project I worked on, which seems to be absolutely of no purpose whatsoever other than a sort of intellectual exercise, was to figure out what activity someone was doing in a wood workshop, whether using a hammer, a saw, or a screwdriver. Now don't ask me what the use case of this is, but it was a problem of, could we use very simple sensors to detect these very common tool use activities? And what we did was we put sensors on people. So this is my colleague back in Zurich, Thomas von Buren, where is he now? And we put microphones and motion sensors, accelerometers, on his wrist. Now if you're using a saw, for example, the signals, so these squiggly lines of electrical signals are produced from that sensor. And you can see the back and forward as it's going up like that, that's him using the saw. So great, you'll be able to sort of throw that into an algorithm and pick out he's using a saw. But there's a problem. If Thomas ever goes to the disco and he's pumping the air like this, the device might think he's using a saw again. How do we differentiate the two? We use the sound. So if you use the movement and the sound and combine them, you'll be able to sort of say, that's a very different sound to using a saw. So that premise of taking simple sensors, combining them, much like you do with your own eyes and your own touch and your own sensations, you combine these things to be able to get a more nuanced picture. A final example from back in the day was studying what you do with your eyes when you're just walking around and you're going your day-to-day business. Now, we could track your eyes in terms of looking at what you're looking at, so having videos capturing the world around you, but it's a little bit invasive. I mean, some would say all of this is invasive. But if we were just to look at the movement of your eye, just how it's moving, is it up, down, left, right, is your eye blinking, we can actually get a lot of information. So this is an example where we sent this some participants to walk around Zurich holding, it was at the time, uncontentiously, the final edition of Harry Potter. And it hadn't been released at the time, so they were reading it and they were really into best motivation for someone is to give them an unpublished book. They were really reading it while walking around and crossing the road and things. And we could look at the patterns of their eyes. And this is an example of it, this squiggly line here. If you were to look in on it, you see these little staircase signals? That's trivially your eye moving from word to word to word, next line, word to word to word, next line. So it's a really, hopefully that should be a quite simple looking signal processing that you're doing there to detect an activity. But in the world, when you're out there, it's really noisy. Lots of things get in the way. Buses get in the way. You've got to be careful you don't get run over, all of these sort of things. So how do we then improve our ability to detect whether the person's reading or not? And that's where you can put in other sensors like head movement or location. So this idea of using sensors to tell what someone's doing. Right, that's enough of my background. What was the point of that? I spent 10 years working on all these wearable tech and thinking, do you know, this just feels I know we're only going to use the data locally to help people, but ultimately all the people that are implementing them are building these devices that then send that data off to a cloud and uses it. It may be helpful for you, but it's also getting recorded by the powers that be. And sure enough, like another 10 years after that, the Apple Watch emerges, which does most of the things I've been talking about. Most of your earbuds have lots of sensing capabilities that can tell a lot about what you're doing, just in the way you move your head and when you're talking, when you're not, all of these sort of things. We're also involved in eye tracking glasses that are unobtrusive. I'm going to return to eye tracking in a moment, but the next frontier really is brain scanning. How do we make a wearable brain scanner that's unobtrusive and doesn't get in the way? And we can send all that to Sergey Brin and all these people to go and analyse. Hopefully not. I'm being facetious. We'll return to brain scanning in a bit because that's partly one of the topics of this whole series of NeuroLive. So my interest, facilitated by people like Daniel and Guido and Antonia Hamilton, was to, how about studying the brain in the wild? How about using this wearable tech to try and understand what's going on in our brain? And what's more interesting is all of the wearable tech was all about how am I doing? How many steps have I made? What's my heart telling me? Me. So egocentric. What's more interesting is social interactions. When are you talking to someone? When are you getting on with someone? Are you enjoying their company? Or even better, is an audience who's watching both of you enjoy yourself, are they enjoying themselves too? Has led to this idea of could we use the theatre as a laboratory for studying social neuroscience? And lots of people, as this workshop would attest, have been working on this idea. And I use theatre in a broader sense, a place where live performance happens. My own background in theatre is, I basically left academia and I became an actor for a bit and then I realised, I'm skinned. So I've come back. And in the process, it's allowed us to look at new ways of exploring this really, really old mechanism for studying social interaction. And I think it was Hetrock that said it, but maybe I'm wrong with that. It's that theatre is real life with all the boring bits cut out, the dull bits cut out. But what's going on in live performance? So many of you are performers, and you know this feeling when you're on stage that you know they're watching you, and you get a feeling whether you're doing all right or not, but maybe that's a misguided feeling. What is that? What is that? Can we measure it? And then can we do things with it? So a lot of my later research, and the research that touches on what's going on with NeuroLive, is concerned with using body-worn sensing in some way to gather data from audiences, from performers, and then finding new ways of exploring the nature of performance or using it to adapt performances. I can't go into all of these topics because we don't have all that much time, but I'll touch on one little thing. Usually when people talk about you're going to watch dance or theatre, you're using your eye. So the eyes are the first go-to for many people about social interaction. I can tell you're looking at me or not, 'cause it's a two-way channel. You can see me, I can see you. But there are some caveats to tracking the eye. It's not that easy. So you could put sensors on people, like eye trackers. So this is a sensor from way back in the 1960s, just a few years before I was born. You've got a camera here, and he's detecting the electrical movement patterns of the eye, which is kind of what I used in that previous study without the camera. Those trackers have gotten a lot better now, and we can actually put them in spectacles. And many of you may be wearing eye trackers as we speak. No, I don't. Actually, almost none of you are wearing glasses. This is really not an academic conference, is it? And the most prominent person wearing glasses is a dancer, a performer. So they're getting smaller, getting to that unobtrusive bit. But there is that truth in it, and this comes from psychology friends here, so Daniel will probably say more on this, but that when your eye is being tracked and you're aware of it, it changes how you look at things. And there's this famous study where they had people to come in and do a task on a computer, and in the corner they had a swimsuit calendar. I mean, I don't know when, 2011, swimsuit calendar, and there was a pinhole camera in the calendar at a specific point. And when they told people that your eyes are being tracked, they just didn't look at the swimsuit calendar. But when they knew their eyes were being tracked, they looked at the swimsuit calendar for a while. And after a while, you forget, and there's follow-on studies on this sort of thing. We tried to follow this up a little bit ourselves, and we were doing another study where we're having two people having a conversation, and we exploring. The setup was like this, a little window pretending. We swapped out the real person for a screen and things for other parts of it. But the bit I want to highlight and talk about here is if you see someone else wearing a sensor, it'll keep reminding you that you're being sensed as well. And we found that effect to a degree. Now, how it works over a long period of time is harder to say. But it was just that little reminder that if you happen to be wearing an eye tracker, I remember I'm wearing an eye tracker, and I'm just going to be very careful about where I look. Perhaps more will be said on the NEUROLIVE project, but I and many of you have had your eyes tracked while watching some of our performances. And there's very interesting data on there, how this feeds into it. So it's all going to be a nice thing to explore. Now moving on for the eye, because we've got the eye, we've got the body, we've got the brain, we've got other things, but those are the ones I'm going to talk about. A particular interest I've been exploring for many years is this idea of body synchrony, of interpersonal synchrony, movement. So we all move when we interact with people. And there are lots of little micro gestures we might make to indicate that we're, say, listening to someone. You may nod your head and so forth. But what if we could, the word weaponize comes to mind, but that's not what I mean. What if we could utilize this to explore what this phenomena is in theatre? When people are watching a performance, do they move their head a bit? Do they synchronize with the performer, or do they not? So we did this recording at the Bloomsbury Theatre a number of years ago, where we put headbands on people with movement sensors, very simple movement sensors. And we let people know they were moving it. We asked them, on stage, could you move your head? And some people moved their head and a bell would ring. There's an interactive element of this, which I won't speak too much to. For example, we gave everyone a different cowbell. So before we told them that their sensors created sound, we made, when they were coming in, you could hear this cacophony of cowbells like an alpine meadow, and it was all coming from each individual moving their head. And some people started to work it out, and they were like, boom, 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 that's me. So it was kind of fun. What we were interested in is looking at the synchrony of people's head movements while they were engaged in this performance. Now, this little video is from another performance, but it's just to clarify the idea. Here you've got a round of actors all wearing sensors. They're wearing, it's another movement sensor, but on the wrist this time. And each of those lines, the squiggly lines over time, represents their movement pattern. And you see them all jumping up and down, that's when the lines are doing that. Now if we can see them jumping at the same time, we should be able to detect that and use it. This is what the squiggly lines look like for the theatre performance we did. So each line represents an individual. The top bunch of them are the spectators, they're the audience members wearing headbands with movement sensors. The bottom lot are the actors that are on stage, and the middle lot are audience members that get asked up on stage at a certain point to do some activities on stage. So the blurring between audience and performer changes. You can't see it massively well here, but you can see Act 1, straight lines. I mean, if you zoom in it, you'll see some movement, but basically no movement from the audience because they're sat there watching. But you can see the actors all moving. Then you move into, there was a science talk, the actors sat still and I got up and spoke. You can almost pick out where they're falling asleep. And then there's the interval where everyone's moving and you can see them all shuffling about. So we can just, from looking at that data, see very roughly what's going on. We can see the arc of a theatrical performance and all its components. And here where there's a game when the participants were asked up on stage, you can see that towards the end, there's some movement patterns there that align with the actors. Now we can do a further analysis of this, which just says, right, well, how coordinated were these people? And the output of that is an example. So I'm showing you some graphs here, apologies, but these little graphs, so the A1, A2, 3, these are the actors. So there's 1, 2, 3, 4, 5, 6 actors, is that right? Can I count? I can't count, or is it 5? Each one represents an actor. And if at the bit where they intersect, so A0 and A3, it's a dark blue, that means they're very well coordinated. They're moving a lot together. And that's picked out from this scene where A3 and A0 are the two people dancing together. So you have a visual representation of something happening on stage, and then we can represent it as a sort of graph in one instance. And you can see the bottom one below, it's a bit more complicated. The light area, A2, it's all kind of white boxes, not interacting with anyone. A2 is the person that's sort of sitting on their own, standing on their own to the right-hand side, not looking at anyone. So you get an idea of what social interactions look like, just using movement sensors. Now, if I scaled that up, you don't need to look at this in detail. The key thing is this is all the audience members and how they interact with one another. You can see at the top left is the actors. They're all working together on stage, and the audience left so. But you get an indication of which audience members are sort of moving with some of the actors, so you can start to analyse those interactions. Curiously, during the science talk, the level of engagement dropped massively, so I wonder why that was. I don't want to dwell on those graphs, but we use this approach for studying other theatrical works. So there's a company called Flute Theatre who we work with, who do work with autistic individuals. And these are many people who are sometimes limited verbal ability and no obvious social connection in some cases. But what we were finding is their movement patterns were indeed synchronizing with some of the actors. So we're uncovering some social behaviours that weren't quite as obvious. I could say a lot more about that, but that's not really where I'm going down for this particular talk. So that's looking at body movement. The body also produces a lot of other signals that are indicative of what's going on in the brain. I believe there's been mention earlier of looking at heart rate and heart rate variability, and galvanic skin response, so the sweat response. Together with collaborators in Japan, we did this project called The Boiling Mind, and it was a series of dance performances, sort of analogous to what was going on with NEUROLIVE. The idea here was that we could study, let's see if this video works. Apologies for the quality of the video. This is our first performance, it's not the later one. So this is together with Keio University in Japan. So we put all kinds of sensors on the audiences. We did eye tracking as well, although that data's not in this data set. Apologies if anyone's got strobe, there's a few strobes here. Close your eyes for a few seconds if that's... all these sensors in real time and feeding it back onto the back of the stage, and in some performances to the lighting effects themselves, adapting them in real time based on the audience's physiology, to which the dancers then would respond and adjust their choreography as they were going, depending on their interpretation of the audience's biosignals. So I won't move on to the next one if we can, if it lets me. So those are the detecting signals, like biosignals, like physiological responses of your heart, like heart rate variability or electrodermal activity, can be quite challenging when you're moving around. For some of the reasons that I mentioned when I was talking about the heart monitor, the minute you start doing other things, the data gets a bit messy. But the wonderful thing about theatre is you're just sat there and we can get nice clean signals from the audience watching things. And that's what we're able to do. So we custom built our own device here for capturing all of this data and sending it in real time over the Wi-Fi system to be able to use it to change the performance, but also to record the data. And one of the interesting things that we were curious about was, this is a choreographed performance. So I am jumping about here because there were several performances. So this is the performance where we didn't alter it based on the signals. It was a choreographed performance, and there were different sections to it. So there's a moment where the girls dressed in suits, there's a bit of playing cards, there's a bit where they pretend to be a puppet, and then there's a bit Romeo where they go to the audience and they bring out a man from the audience and they get him to do things on stage. Now, we're looking at the audience's heart rate responses here, and we can see the patterns of them. And so if you were to look, for example, just at the blue line here, you can see the average audience heart rate variability as time goes on. And when Romeo happens, when they know someone's about to get pulled up, you start to see increases. So we could see patterns, but what was interesting about it was that those patterns that were averaged across all of the audience was the same for pretty much the same for every performance. And they aligned with the choreography that the choreographer had decided on. So we could make a mapping between how we've planned something to be and then what the body signals tell us. There's more to be said on that that goes much deeper with the NEUROLIVE project, but this is just a sort of precursor to that. So you can detect signals from the body. What about manipulating them? This is where it gets a little bit on the edge of well, see how you feel about this. Has anyone ever felt frisson? Do you know? Can anyone know what frisson means? Because I always struggle saying it. Goosebumps, that feeling on edge, something's making you go ooh. And what is it that triggers it? Often it's something that's, you know, it's emotionally engaging. It's got a sort of real, it's coming from the gut, and it's a real signal that you can't necessarily control. You can't say, right now I'm going to have goosebumps now. You can't decide on it. And can you detect it? You could put little cameras on your skin to detect, like they start bumping up and the hair's standing on end. Or we could use electrodermal activity, this sweat response, which can be a proxy for it, can be an approximation of it. So that's what we did here. Well, there was a pianist playing a concerto. It was a beautiful, beautiful piece of music, and I wish I had a video of it, because it does give you thrills. But it turns out that some people didn't get frisson while experiencing this piece of music. So what we did was, we got them to go and watch it again, but this time we stuck devices on their back, which that provoked them to, it stimulated them, shall we say, heated them up or cooled them down, depending on what we wanted them to feel. So if other people near you felt frisson, we would detect that and then force the others to damn well feel frisson in the kindest possible way. So there's the people wearing these devices at their back. And the idea is, can you learn these responses just from being subjected to it? It's a bit like Clockwork Orange, if anyone has seen the film when they're watching. Yeah. Anyway, that was in Japan. We're not doing that here. In the final thing I'm going to return to is studies on the brain. So I showed you this image here, which was reported in Nature not that long ago as a wearable MEG scanner. Now, MEG is really hard to do wearable, so in fairness to them, it's magnetic encephalogram is not easy, and typically you've got millions of pounds of equipment and your head is locked in a brace. This is wearable in that they can sort of move their head a little bit like this. That's not the wearable we're talking about. We want something that you can actually walk around with. And that leads us to using wearable FNIRS, functional near-infrared spectroscopy, can't say that either, exploring what's going on in the blood flow of the brain in different social situations. So we've been doing work with Antonia Hamilton on that. She's done a lot more than that. And then looking at the electrical signals with Guido, Laura, and everyone in this particular team, the NEUROLIVE project. And we got some nice wearable EEG scan, which I'm not sure if there's a demonstration of, but one of the things that I found interesting about the brain was when you look at studies, neuroimaging studies, they're invariably based on repetition. You see a picture like this, your brain lights up when something happens and shows you a little kind of something not similar picture of your brain with big coloured regions. That is not a one-off recording. It's not from what happens at that moment. It's invariably done as a statistic over like a dozen or so recordings. Someone in a scanner being subjected to like a visual stimuli, and then they look for patterns. We were trying to think, well, can we do that in the dirty, in the real world, in the theatre? And theatre provides you an opportunity because you've got scenes with beginnings, middle and end. You've got relatively defined choreography, and you can repeat it again and again and again. So exploring that idea of can you record your brain signal and then you do an activity and you do it again, and we can average over that and give us some indication of neural correlates. So that was a kind of exploration of that. Another brain project, this is a side project, this is one I'll finish on, is connected. This was put together by Frederick Peng, my PhD student, former PhD student, called Moving Photon. And he built this beautiful big installation. You can see a bit of it there in the corner. I'll show you the video, where there was robotic arms all around the space, and this big tube all going around it. And the robotic arms moved up and down, and the tube changed lighting effects. And this dancer danced in response to the robot, so he danced with the robot. But the critical thing is, that robot was controlled by the brains of two individuals who were sat watching it. So we used our NeuroLive EEG system to, in real time, and Laura worked on putting that together, to pull out some of the neural signals and feed them in real time to be able to create this performance. So you could really say it's a co-created performance where what the dancer was doing was in response to the environment, what the environment was doing was in response to the audience, and what the audience were doing was in response to all of it. So you've got this big loop. And this gets back to this idea of, in liveness, there's a loop, there's a feedback loop. And how do we handle that? What do we do with that? It happens in all performance, it doesn't need technology. The classic cases of the actor who tries too hard because they feel they've lost the audience, so they go harder, but they lose them even more. How do we make this loop work? How do we make it flow and create a beautiful performance without getting in the way? And I think wearables have a role to play there, and what they might be remains to be seen. And with that, I will pass you on to Jamie Forth. Thank you. I think we're having questions in the Q&A session, aren't we? If there's any. Yeah. If there's a burning question now, that's all good. If not, you can. Burning question, yes.
How do you find an artist to be able to react to the audience, wearable lights or?
Yeah. So if you are an artist and you have the information from the audience beyond the faces, like the brainwaves, how do you train them to be able to better understand what that means and how to better react so it is effective rather than losing them?
Yeah, that's an interesting question. So I don't think it's my job to train the artist what to do. I can show them what we can do, and then can they interpret it or not? And how could you work, how do you co-create these pieces? Because if you're talking about creating a piece of art, they're the artists, they're creating this piece of art, you can contribute towards it. I mean, I'm pretty sure the Doug Kennel Hill people will have more to say on this as well, because that's basically, you know, that's a creative decision. So I wouldn't instruct anyone. You could say, oh, that probably means your heart rate's up, but it might not.
So it's the job of the artist to figure it out.
Yeah, I mean, you can co-create it. They can suggest, oh, could you give me a bit of visual, a bit of audio? But on that point, I think Jamie's going to return to this as well with feedback.
Hello. So yeah, I'm Jamie Forth. Been involved with NeuroLive the past couple of years, both as an artist, sound person, and doing some technical stuff. I don't know why I've got yellow dots on my slides. They're not on my screen. Anyway, so I was trying to think of all the various things I could put together for this talk, and I kept coming back to time. So I'm going to connect some projects I've done and the work I've done on NeuroLive all around this concept of time and synchronization and how those things kind of come out in both artistic and scientific practices. So just like that. So I'm going to start with live coding, just because this is what I associate with actually NeuroLive. It was the first thing that came to my mind when Jamie and Guido approached me about this interesting, intriguing problem of how do we synchronize EEG devices in live performance. And my first thought was, oh, this is easy. We do a very, very similar thing in live coding. So if anybody hasn't seen live coding before, here's a quick video. This is quite old. So it's basically a practice of writing code and editing code as part of performance. So it's a kind of performance practice that is inherently technical and hopefully artistic and fun. But one of the problems that I came across, or many people came across, when this became a thing that was possible, is how do you play together? Because it's not quite the same time as playing acoustic instruments. Being a musician playing with other musicians, there's lots of interesting things that go on there about synchronization. But in this context, we've got computers in the way, which have some particular disadvantages for responsiveness and synchronization. So part of this work, so this is about 15 years ago, we tried to solve this, and we did very well. We came up with a way of synchronizing multiple computers, guaranteeing sample accurate scheduling on a local network. And to tie that back to NeuroLive, that was what I thought would be easy to do with the EEG devices. But the problem with this is that, or at least 15 years ago, it required cables. It required physically connecting stuff. And Guido pointed out quite quickly, no cables. It would be non-negotiable, no cables. So this was kind of my point of departure from having done a lot of work in how you synchronize computational or computers together. How can we translate that to wireless? Another example of my sort of more creative practice, also related to synchronization and creating a sense of synchrony in kind of remote collaboration. So working with performers, working with visual artists, working with choreographers, and myself doing sound and the coding stuff. This was a project that tried to work out how can you collaborate on dance performance pieces remotely. And yes, this started during the pandemic. A brief example of that. So this is just a short clip of an installation we did in Singapore, although I wasn't there. The point of the project was that I wasn't in Singapore, I was in London. But my presence was in the space in various different modes, temporalities, liveness, we could say. Okay. In the interest of time. And then my kind of final project before I move on to NeuroLive specific stuff is my long-term fascination with musical time. And so my background is as a musician, and I've played music all my life, both with a computer and longer without actually. But I've always been fascinated by the time aspect of music. So I think it's an amazing thing when musicians play together and they listen and they respond and they are doing this constant dance of being in sync, playing together, listening and responding and contributing. And one of the things that I was fascinated to kind of research a few years ago was how do we represent the kind of human or musical time? Because it's a very different kind of time to things that we might do with computers or measure, or our sense of time can shift in lots of different ways. And music is an interesting context to study this because it connects to things like expectation, and musical emotion is a long history of how that connects to expectation and surprise. And I was interested in how we can represent and model musical time. So it might be as simple as tapping your foot, or obviously it connects to dancing as well, moving in synchronization, moving in sync with other people or other stimuli. And I did some work coming up with how can we talk about musical time that can shift, that has structure, it has layers to it. So the top left-hand corner would be like a very, very simple 3-beat rhythm or a metrical cycle that just has 3 pulses. But you can divide your cycles into different numbers, you can create different kinds of groupings within those cycles, and it's a very interesting kind of way of probing how humans slice up time to create musical meaning. So all this stuff is kind of background. Then NEUROLIVE stuff, this is a bit more about the technical problems that came up were regarding how do we synchronize multiple computers or EEG machines over time. So the first thing to point out is that because of using Wi-Fi, we could not sync all the computers to one clock. They are all running, so we kind of went the opposite extreme. We let them be completely different, and then we would fix the problem later. And that's been a big part of the work I've been doing. So the data that we actually record from these multiple independent devices, we just let them have their own time. We don't even try to synchronize it. We just let them be in their own times. So in this, the top plot is just test data of a counter. So the line going diagonally upwards is just counting samples. And we can see that this device is counting samples in a very different time base to the second device. So somehow we need to put these times together. We need to kind of reconcile these temporalities. But it's also worse than that. It's actually temporal anarchy or something. All of these devices, they don't even have the same notion of what is real time. They are all running very, very slightly differently. And this is a problem. But it's something that we can solve. So the lines that are sliding downwards are clocks that are basically getting slower over the duration of a performance, say. But we have some clocks that are perfect. We have a few clocks that are perfect straight lines. And if everything was a perfect straight line, that would be fantastic. But it's not. So we have to deal with this, all these different devices not even counting time, measuring time in the same way. We came up with a solution. I'm not going to go into massive details about the solution, but we effectively merge all these different time bases together, and that, in theory, gives us alignment between all of these different streams. And I think probably the most exciting test that I've done with this, that gives me the most confidence that this works, is a test that Guido and Laura helped set up, which was incredibly high-tech. It involved a copper plate and some wires and electricity so that we could physically send an electrical pulse that came from one place, and we picked it up from multiple devices, but we knew that it's electricity, it's in the world, it's physical, it happened together. So once we do the alignment, these things should line up. And they do, and it's quite encouraging. So this is what, if we just zoom into what one EEG device recorded, it's just a pulse wave that steps between high and low values depending on whether Guido pressed a button. And then we slice that up and we find very accurately what these transients are, and then we do that for every device, and then we calculate the error, because there should be no error if it was perfect. It's not perfect, but it's pretty good. So the x-axis is all the devices that we used for this particular test, and the y-axis is the error, basically. How many milliseconds are they off from what we know happened, this physical event in the world that they should be all locked to. So we're plus or minus 4 milliseconds, which is pretty good for this, and that corroborates with other similar studies of people evaluating this stuff, although they normally do it in laboratory conditions with 1, maybe 2 devices, not on the scale that we were doing it, but we get really good results, which is, I think, good enough for a lot of the analysis that we would like to do. And just a sanity plot of, are any of these devices warping over time or anything like that? And it appears not. So I'm calculating everything relative to EEGE, which is, so that I'm taking that as a reference because it was the median timed device in this very small scale of milliseconds. And every other device is either 1 millisecond or 2 up or below that. So that they're all kind of keeping in sync over time, roughly. Our system seems to work. Then the next step is it's not good enough just to get everything into one time base. We have to get everything sample aligned to be able to do the EEG analysis. So there's an extra step which just takes all of these time points and it slices them up into discrete samples, so we have a discrete index of every data value that was recorded. And this is just a sanity check. Does this break our synchronization? And no, it just discretizes the error that we saw in the aligned times. So again, we're plus or minus 4 milliseconds in the worst case. It's very often more plus or minus 2 milliseconds. And over time, it's roughly the same, slightly different, but we're not introducing any errors or biases in this process. So summary, plus or minus 4 milliseconds. Mean is less than 1 millisecond, standard deviation 1.2. And there was 1,170 discrete events that were measured to create this data. So Guido pressed the button 65 times, and we have a time point for on and off, and that gives us the comparison with the reference. So there's quite a lot of values here that gives us confidence that this works. The other thing, so the final thing, is just does this actually work for the neuroscience data? Is it good enough to give us some effect that we would, or the real neuroscientists would like to see? So I've just done some very quick analysis of the P300 section in snakeskin. So if you saw that, this was the section where you listen to beeps, and every now and then you have a surprising beep. And these pictures are what happens when you hear the surprising beep. Your brain registers the difference, and there is a response, and in the literature, it should be around 300 milliseconds. And in the final performance of snakeskin, this was the best plot I got, and it looks like you would, well, neuroscientists might correct me, but this looks like kind of what you would expect, but at least it gives me confidence that the synchronization is good enough for the kind of neuroscientific questions. I've got plots of everyone. I'm showing them backwards because they seem to get worse, so somehow we got better over time. I don't know how, but we get similar responses, we get similar peaks around 300 milliseconds. So this is a thing we're kind of looking for, this signature dip, rise, and then another dip, and it moves around the skull in different ways. Anyway, so these ones are not quite so good, but the effect is still there. This one's very messy. Yeah, okay. Then the final thing, to bringing back the talk to kind of art and science, one of the things I like to do is turn data into sound. So I was going to just finish with a short sonification of one of the, what am I doing, snakeskin performances. So I can do this, perhaps a minute, is that okay? We listen to something for a minute, time. So this is 60, so it's just over an hour performance. I'm condensing it into 1 minute. So that was 11 performers, 11 EEG participants, and it's really, it's one of the sound things that I was doing live, which was just taking the average of all the sensors on the head and using that to control frequencies, and then the clicky or the kind of more pitched melodic sound was when the standard deviation got bigger. Like it's that kind of simple, but having heard that a few times, it is quite interesting that you do hear these kind of fluctuations over different performances. And yeah, it's quite fun. All right, thank you.
Any pressing questions?
Oh, sorry. Was that played during the performance?
It was live during the performance.
Okay, great.
So this is a neater version of like the whole performance in one go.
Summary, yeah.
In the live performance, I was taking different people or different sets of people and adding up at specific moments.
Yeah. Contribution to live play.
Yeah, it was live playing in there too.
Yeah, we'll have more of that at tomorrow's morning session, where we will delve into snakeskin in the wild in more detail.
All right, good afternoon. It feels really weird to give a talk not wearing shoes. I didn't anticipate that this would really make me uncomfortable, but I'll do my best. Well, thank you very much for having me along to this session. So I've been part of the NEUROLIVE team, sort of in the background, and whenever I see the work that they do, I'm just amazed at the sheer ambition and amount of work that goes into all of it. It's absolutely staggering the way they've just taken this incredibly difficult intellectual problem, heaped on a lot of really difficult technical problems, and then added in art as well, right? And I think we should acknowledge how insanely difficult what they've achieved is and the remarkable steps forward that they've done. That's all by way of sort of apologizing, because in comparison, my stuff looks really lazy, right? Because it is not that ambitious. I'm interested in very similar questions about experience of things and collective experiences, but I'm quite lazy and haven't gone to all these lengths. So I'm going to present you with some work for about 20, 25 minutes, looking sort of at the same questions but at the margins of these things. But I think the answers that we're starting to find eventually will link up with some of the incredible NeuroLive work that's been going on. So what I'm going to talk to you today, I call it collective experience is the broadest title. What happens when we get together and experience something, or even just experience the same thing at the same time. And already we're in that sort of territory of thinking about, well, what is that liveness? What is that co-experience? Or even framing the question, we're getting towards the same issues. And the particular measure that I use, that I'll explain, and of course Jamie's have talked about it already, is to look at synchrony, particularly physiological synchrony. And if you think about physiological synchrony, people's bodies beating in time with each other, moving, you might think of some peak experience like these people watching a football match, right? When you are jumping up and down and screaming at the same time because your team has scored a goal, obviously you're engaged, obviously you're having that shared experience, obviously it's a peak life experience. What we're trying to look at as we study that a little bit, but we're asking the question, is the same thing going on when you're sat very still and respectfully watching a dance performance that maybe you do or do not understand? Well, is the same thing going on? Is it the same mechanisms at this very different type of experience? My hypothesis is it's very, very similar. So this is the particular thing we did just post-pandemic. That's why there's all masks everywhere, and I'll show you the data from this, from that later. Okay, so just to take a step back, as I'm sure many of you know from your actual experience or from knowing a bit about the literature, what we call behavioral coordination, moving your bodies in the same time, is a really common biological phenomenon. Jamie's already shown us some great examples of it in dance and so on. We've been seeing it throughout this project. But of course, you get animals doing it all the time. They move in sync for particular reasons. This is a group of male flamingos who are flexing at the club, showing off to the ladies. The degree to which they move together means something in that species. We can see it. That's Anthony Scaramucci and Donald Trump. Scaramucci worked for Trump for 10 days, and in that time copied every single one of his gestures. In mammalian species, that sort of behavioral coupling is linked to affiliation and bonding and respect and power and all these other things. In a different way, in the bottom corner, that's two undergraduates in my lab. I'm trying to get the motion tracker to work. I left it data, and that's two 20-year-olds doing what they do. That's flirting. That's what that looks like. See, the guy on the right tells a joke and they rock in time with each other. You can put a number on how much they're moving in time. That tells you how much she likes him, how much that joke was. So at all these different scales across all these species, we see moving as expressing something and being really important psychologically. Changes levels of conformity and obedience, right? Wider armies march in a straight line slowly forwards. It's been a bad idea to do that since the invention of the machine gun and the cannon. Every army still does it. Why? Because of the psychological effect. It changes levels of obedience and identity if you move in sync. So we know behavior has this powerful connection to psychology. And what we've started to explore, what's been in the literature now for about 10, 15 years, is demonstrations that below the skin it matters too. So it's not just am I waving my hands up and down in time with someone else. If you measure stuff about that physiology, using some of Jamie's clever devices, you also find a signature of this synchrony. So, for example, if you turn and stare at the person next to you, gaze into their eyes, if you like that person, you will synchronize your heart rate with them. And it's not magic, it's partly through respiration and you picking up their subtle behavioral cues, but you'll start to synchronize your rhythms if you have a connection with that person. We know that from couples and therapeutic situations and mothers holding babies that they have a connection to that's weaker or stronger. We can also see it in families. It's a little hard to see there, but that's flames on the floor of a Spanish village. And this is one of those crazy ceremonies when they walk across the hot coals being watched by all of the village. This is Ivanka Konlakova's work. And she put heart rate sensors on the people walking across the fires and the whole village watching. And what you get is heart rate synchrony between the spectators and the walkers that scales depending on the familial connection. So if that's your son walking on those hot coals, you are tightly clamped in. If it's your brother, a little less, your cousin, a little less too. So you can put heart rate sensors on that village, track them during the ceremony, and read off the family trees of that village. That's how connected these things are. We know that in team sports as well, this sort of stuff matters. If you exercise and synchronize your press-ups with the person next to you, that changes your endorphin levels, it changes your pain threshold just because you've been engaged in that little bit of physiological synchrony. And our sort of hypothesis going into this has been that all of these things are happening somehow in an audience. That in some way, that shared experience might be feeding into changing hormone levels, to changing affiliation levels, to telling us something important psychologically if you can measure that physiological synchrony. And that's our hypothesis, and of course we've been looking at in NEUROLIVE as well. So just a little bit of motivation to say, well, if you think of these fitness trackers, again, the sort of thing Jamie looks at, you might say, well, yeah, that's really useful for jogging or for yoga, but how much can this tell me about what's going on inside my head, right? Those two things are quite distant. Whereas, in fact, these trackers, these physiological devices, can tell you a lot of purely psychological stuff. So this is an experiment we did that just had people listening to an audiobook of something, like the Game of Thrones, or watching a TV version of it. And we tracked their heart rate, their physiology, their skin conductance while doing this. And we asked people, which did you find more engaging? And everyone said, well, the HBO version, right? They hired out half of Croatia to film that. It's incredible CGIs. That was more engaging. But then when we looked at their physiology, they were more engaged at the wrist. Their heart rate was going up and down. Their skin was pumping out things. Their endorphin system was changing. Even their body temperature was fluctuating when they were listening to the audiobook. So there's this weird disconnect. Their bodies are working harder, their minds are working harder listening, but they say they prefer the video. Well, what's the difference here? When you're listening to the audiobook, you're creating that world of Westeros. You're generating that, you're imagining it. And that's cognitive effort, that's emotional effort that we can read off at the wrist. I have to give all that thing because if I just say, I can measure your imagination at your wrist, that sounds hokey and stupid. But once you see the data, how else do you actually explain that? That's a little bit of imagination that we can measure. So that's just motivation. Jamie made this point better already, that these sort of devices are really telling us much more than health and fitness. They can tap into all the cognitive emotional processing we're doing too. So we're interested in this question. We took these devices. These are from a sack of watches that Guido gave me from another project. And we took them to the West End to try and see, well, can we track this shared experience of people at a musical? We did Dreamgirls the musical, so we got free entry to do that. And we measured the heart rate and tracked it across time. And what you see there is the red line is about 20, 30 people watching that live theatre thing. The orangey line is people watching the same thing but the movie version, just with 10 of them. And they're nice because they're quite matched, the stage and the movie version, slightly longer, but you can change the times. And what you get here is peaks at the same time. So why are there peaks and troughs all over this? Well, that's narrative, that's story, that is. Right? That big peak in the middle, that's where, I've forgotten the character, Effie gets kicked out of the band. No Dringles fans, that's okay. And then she divorces her husband, and then they all get back together again. Right? So that's emotional reactions to that story being experienced by people in the same way, driving their physiology, so they have that common trace. Right? If that heart rate had been random, we would have averaged out, that would have been a flat line. So that's just average heart rate as you go through that experience. You can also put a number on how synchronized they are. And by synchrony, I don't mean, as Jamie was talking about, exactly on beat, not synchrony in that sense. It's more coordination, just because people's heart rates are different, right? People are healthier or not. So by synchrony, I just mean my heart rate is going up and yours is going up at the same time. Not to the same value, but we're sort of coupled in some way. And when you put a number on this, loose synchrony, you could call it, you see an even bigger difference between the theatre and the movie. Really, you're getting much more physiological coordination than you are when you're having that shared experience. So you guys are going to be more coupled physiologically right now than the people, hello, watching from the camera. They're having a different experience as a result of your co-presence, my hypothesis would be. And we got quite interested in this. We started to take these little devices. This is us in the Westfield Cinema in West London. People watching Aladdin the movie. Because one question is, do you have to have live performance, or is this just a shared experience drives this? And again, we can see people having this coordinated response, where you get a big peak in heart rate and electrodermal activity at one particular moment when Aladdin gets his first kiss. which is very endearing. Everyone's hearts flutter just a tiny bit in the audience. Now, that's not so surprising, right? There are exciting bits of the movie, there are boring bits of the movie, of course we'll see it. But the interesting thing is we also put a number, again, on how loosely synchronized people's physiology was while watching that movie. They then exited the movie, they left the Westfield Mall, and as they were leaving, we said, how connected do you feel to the people around you? Bit of a weird question, these just random people in a mall, but how much do you feel like a part of a group? And what we found is the degree to which they felt they were affiliated, bonded with each other, correlated with how synchronized their heart rates were. So they're watching this movie with strangers, but they walk out, and if they synchronize their physiology, they feel a little bit closer to those people. And we can measure that. It goes up the more synchronized their heart is. It goes up more if they watch a movie together, rather than just sit in a room and read a book together. So this is really exciting and interesting. Thought we had big news. We can demonstrate that being in the same room with lots of people has an effect. And then what happened? The pandemic. And it was suddenly illegal to be in a room with more than 6 people, and it was incredibly obvious to everyone there's something special about these collective experiences. So our big news story was globally, no one was interested because it was also painfully obvious. But that's what we think we're looking at, that thing you really missed in 2020, just not being around people and that energy that you get from it, that's what we think we were starting to tap into. In fact, we did this is data we collected the day of the lockdown. We had to rush it a little bit, asking people to watch Carmen? I can't remember, one of the operas, and then measuring their heart rate and asking them really quite advanced questions. Well, not advanced. I didn't think this would work at all. How captivated were you? How emotional were you? How spiritually uplifting did you find that experience? The more spiritually uplifted you were, the more you were synchronizing your heart with the people around you. Really strong correlations that we got and then couldn't follow up for 3 years. Oh, and this is the football version that we did during the pandemic. Again, you saw the data here previously. And the uninteresting thing was, of course, when you score a goal, all of this shoots up because you're screaming in someone's face, you're going up and down, up and down. That's the uninteresting thing. The interesting thing on this experience that Robin here did was sort of right at the end. This is a very close football match. It was 2-2. It was really tense. And then the final 10 minutes, anyone could have won it. It was really tense. And that's when you saw a difference between these two sets of fans. The Liverpool fans got really nervous and started to look at their watches, bite their fingernails literally, and go really quiet. The Liverpool fans got louder and louder and louder and started to chant. And you could really see they were the bonded tribe compared to the Man City people. You could read it off in their heart rates, and you could see how they were responding to this moment. They came together or they came apart. So again, we think these things are really tapping into that shared emotional experience. Now, this is a slight tangent, because the pandemic hit and we couldn't do stuff in groups, and we started to think, well, maybe we have a more general measure here. If we can put a measure on the synchrony that people experience, that seems to be telling us how much they enjoyed that experience. This has been shown with synchrony in brain data by Domachowski a few years earlier, and we thought, well, can we extend that logic? If we just show people anything, like a clip of an advert or a movie trailer, we measure their physiology. In this case, we use the skin conductance because it changes more than heart rate. And we put a number on how similar people's responses are. Is that telling us anything? And we found that, yes, it does, surprisingly. So we found we were able to predict, by looking at the physiological synchrony of people watching a 1-minute movie trailer, how much money that movie makes in a year's time. It seemed to be telling us something about that engagement. Again, it sounds slightly magic when you say that. The easiest interpretation we have is, if you're really into this thing that's on the board, if you're really enjoying that, then all of you will have the same brain response. If you're bored of what I'm saying or what's on the screen, you'll get bored in different ways. Someone will have a sleep, Guido will go on his phone, you'll all look very different. So that physiological and that brain synchrony is a measure of how much are we all focused on the same thing. And that's why it taps into engagement, we think, and it gives you this very powerful readout of how much your brains are dedicated to this one common thing that we're sharing. And we think it can pick up on things like engagement better than explicit judgments can. So this is an advert that I'm going to show you. It's quite a famous advert. And on the left is data from an advertising company that asked people to press buttons how much they liked it and just report verbally how they liked it. Or the curvy line is just seeing if people smile. And what you can see here is those measures of explicit engagement, they get a peak at the end. But if you look at our measure, this is continuous physiological engagement. How similar are they moment by moment? We get a big peak at the start. I'll just shut up and play the advert because it's a cute advert.
You'd have to throw that one back, Mr. Thompson.
There's a glass and a half in everyone.
Oh, so it's very sweet. And again, if you look at the end, everyone smiles at the end. Most people smile and we get a peak of engagement. But what we found is this peak at the start as well. So why is that going up there? Because there's no payoff, there's no joke. Well, our hypothesis is that's the narrative engagement. That's where you're being hooked in what's going on. There's a guy who's really grumpy, there's kids next door, you're worried he hates them and they hate him. That's when you're drawn into the story. And there's no emotion, there's no facial expression that means I'm worried about that old guy, right? There's nothing you can explicitly say, but you are hooked and you are engaged. So we think these measures can tap into things that you wouldn't necessarily be aware of and could articulate if you're filling in a survey, and they don't correspond to an expression that I can measure. But you can read them out in these sorts of measurements of physiological synchrony or even brain data, we hope, in NeuroLive. So we got interested in this. We tried to ask the question, okay, if we've got this tool that can tell us how people are being engaged by narrative or being engaged by a stimulus, by a video, how can we flip it around and say, can we ask questions about what that narrative engagement looks like? Can we break it? Can we make it more or less to try and understand what it is? On one hypothesis, you could say, well, I'm talking about narrative, but how do I really show that, right? Maybe it's not narrative, it's just moments, right? Maybe it's just, those movie trailers have things exploding, they have beautiful people kissing, they have car chases. It's not the story, it's just the individual stimuli are interesting. And we thought, well, that's valid. So how do we show the same thing to someone but destroy the narrative? What we did was got these two little short videos, a whole set of them. And this is a story about a TV who's an animated character, but he wants to watch TV. So he has to plug himself in and move the mirror so he can watch himself. It's a cute little 30-second video. And what we did was cut it up and move the scenes around. So you see the same things, a TV moving around, plugging stuff in, but if I move those scenes around, the narrative is destroyed. The audio visuals are the same, so it's not just that you're responding to, but you get the story in one. And it's when you get the story, we get that boost in engagement. What else changes the sort of engagement that you have with things? Well, another thing that we thought seems to be relevant, as in, well, it's everywhere and I don't understand it, are these reaction video things, right, which are all over the internet. Twitch is based on this whole thing. You go to see a video of something like Johnny Cash, but then you don't watch that, you watch people watching it. Again, this is the whole of Twitch is based on watching people watch stuff. Someone hears something for the first time. It's an incredible subgenre of YouTube that I had no idea about till I started this. And I thought, well, what the hell is going on, right? Because you want to see Johnny Cash, don't you? Why do you just want to see people sat there? But these things are amazingly popular, and I don't particularly understand why. But an undergraduate asked this question and found these matched videos. So we had Johnny Cash in either case, but another one, you had people reacting to it. And in fact, they're not really reacting, they're just really sat there. We chose one where people are not jumping up and down, they're just there. And what we found is them simply being there increases engagement. There's a little effect of just having that shared watching, even though these are strangers in the background on a screen, that increases your engagement in what's going on. They are boosting your enjoyment of it, even though there's no interaction. So this is what I mean by us approaching the NeuroLive questions from this sort of distant, cowardly angle, right? We're looking at what happens when you add people into an experience, not a really rich live one, but a tiny bit of video, and already we're finding effects. So just having people there matters. We did some stuff with Eurovision, that's the German Eurovision entry for Guido from a couple of years ago. And we had people watching it alone in cubicles or watching it 6 at a time in a slightly bigger room. And just having those people with you boosted your engagement, boosted your physiological synchrony. These are not friends, you're not talking, you're not laughing, you're not drinking like in a Eurovision party, you're awkwardly sat there. but just that little bit of a shared experience, that maybe shared glance between people or something, is boosting their engagement by this physiological measure. Oh, here's Jamie again, in case you hadn't had enough. And we got interested, well, what is this telling you? So we did a series of experiments where we had actors like Jamie over there do audition pieces. So they're reading from a script, they're reading the same script as if we're auditioning them for a part, in not unrealistic conditions if you are an actor. And we had people watching them. And we're interested in, well, how much are you synchronizing in general to this scene, or specifically Jamie's rendition to it? And we found all these really interesting interrelationships. If we measured the synchrony of an audience, they were synchronizing more to the better actors, as in the ones who got the role. We said, who would you give the role to at the end? So increased synchrony means that's a better thing. We also found they were synchronized specifically to each actors. So the people who watched Jamie do one scene would synchronize with each other more than people watching another actor doing exactly the same scene. So it's not just the scene they're synchronizing to, it's Jamie's reading of that scene his audience is synchronizing to specifically. So it's performer-specific, this sort of engagement. Not only are Jamie's audiences synchronizing with each other, they're also synchronizing with him. So if you watch him do this performance, and he's got a little sensor, you can't see it on his finger, he's got a sensor, people who are watching Jamie and enjoying him are specifically synchronizing with his physiology during the performance. So it's not just the audience are sharing this thing with each other, we can read it off in their physiology. The audience is sharing something with the performer themselves that is telling us something, we think. So this is a very interesting question, I think. And again, Jamie was getting this sense of if you're a performer, that connection you have with the audience, or at least you think you have, what is that based on? What is this energy you're sensing? Where we're starting to be able to get little snapshots of the data, we think. Another question we can look at, again, is NeuroLive relevant, and this is Robin there's PhD is looking at all of this, is so far I've just been talking about the audience. Apart from when we had Man City and Liverpool, it's just the audience as one big mass. But how do differences between the audience members, or how does their bonds and affiliation shape this shared experience? It's a very complicated way of saying it. What we did was put people in a situation, again, this is my cowardly version of an audience. I wouldn't do a live recording because that's really difficult. So we faked an audience in this way. Our people are in an experiment and they could see videos of other people like they're on a video call. In the corner, and these are all pre-recorded, but in the corner was a live video feed. You can see it's me, right? I'm trying to fake it in my thing. So if you're in this thing, you thought this is a real Zoom experience, because there I am live, here are other people, we all must be seeing this at the same time. And it was a little bit of a sleight of hand. So the shtick is you're having this Zoom audience live thing, like the sad days of the pandemic, where we watch live theatre and Zoom calls. And we're interested in, well, how does your feelings about these other people on the Zoom call change what you're experiencing? So what we did was had two different videos. This is from a popular YouTube channel where people have debates and discussions. One of the debates and discussions was about a big political issue. What was the issue, Robin? I think it's abortion. We went for the hot topic ones, right? That really tears people apart in American context. And the other one was still there, debating and arguing, but it was lighthearted. It's about turn-offs that people do on a date or not, right? So there was disagreement, but the stakes weren't so high. And before watching these videos, and we measured your engagement in these videos, we changed what people thought about each other. So in one case, we had a dissimilar group. And we set this up by, before you watch these videos, I'm going to poll you on a few questions. Do you think we should worry about the environment? Do you think students don't have enough money? Do you think more should be done to help people in need? Really sort of bland questions like this. And in one case, you saw your response, and you saw everyone else's response on one of these Mentimeter sort of polls. And in the similarity case, you give your response, yes, I'm worried about the environment, and everyone else dragged the sliders over to the same thing. So you're with peers, you're with people who pretty much agree with you. In the dissimilar response, you gave the same answer, because everyone pretty much does in this context, give the same answer. But you saw other people move their sliders to the other way. Think, hang on, no, is this like a MAGA thing? What's going on, right? You get that distance that, oh, these people do not agree with me. So you're in this Zoom call with people who have your values, or you're a bit awkward, they have different values. You watch that same video, you have that shared experience. What happens to your physiological engagement? Well, when you're watching that political ad, it's exactly what we predicted. You are more engaged, you're more physiologically synchronized with the people whose value you share. These are your people, you're watching a difficult political thing, but you synchronize them all with the group around you, the people when you're watching the same thing. That made sense to us. But then, when we looked at the dating video, it went backwards, it went the other way. You have more engagement, you have more shared physiological synchrony when you're watching this funny dating video with people you think are Trump supporters. Completely backwards. Didn't make any sense to us. Our best explanation, and this is a hypothesis that you might have better ideas, is that if that's a political discussion, then political stuff matters, right? That's what we're talking about. The lines have been drawn in the debate, and you get very tribal about it. But the dating thing isn't tribal, right? I've divided people on political grounds, then they watch a funny video, and they feel different to each other. And in general, what do we do when we're around people who feel different to us, even if they might be Trumpists or people we don't like? We compensate and we're really nice. We're much more pro-social than we imagine. So when you're surrounded with people who you think might reject you, you might reject them, it's very rare that you're actually rude to them. It's more likely that you nod and smile more, literally nod and smile more, that you'll copy their body language more to compensate for that horrific awkwardness of being different. So we think what we found, and this is, I'm trying to figure out how do you map this onto audiences, right? There's some situations in which feeling different to the people around you means you have to invest more, means you have to nod and smile more than if you feel like you're part of that group. So there's this really interesting dynamic between, do I fit in here? How much effort do I put into fitting in? And people will compensate when they feel a little bit isolated, because that's the very worst feeling of all, that ostracism, and people try and compensate for it. That's just a hypothesis, we have no idea. The final experiment I'm about to tell you about, yeah, that's about right. Again, we're interested in this idea of, we're watching a bit of art, a bit of video, or a bit, a performance. What's the connection we feel with those people on stage? And can we manipulate that? Can we change that? And can we measure something about it, that specific engagement? So we got interested in this. It gets into questions of empathy, with identification, with what's going on. When I watch a James Bond movie, do I feel like James Bond? What does that enjoyment look like? So we did this experiment that I would say is like embarrassingly heteronormative, but that's fine, right? We just did men and women because it's easy to manipulate and get characters for. But we realized we're glossing over some very important differences here. So what we did was we got a set of scenes with a male and a female character who are arguing about something. And they're all scenes where both people are in the right and the wrong. They're all quite tense scenes. And we're asking people afterwards, which character did you empathize with? Who did you think was in the right? Who did you agree with? So they're really quite finely balanced. So this is a scene, I'm not going to play it for you, but in this scene, the woman goes through the man's phone and finds flirty text messages with a co-worker. And then they have a big row about it. Quite tense thing. And what we did to manipulate this was say, well, let's bias people towards one character or another by giving them information, because often that's what empathy and agreement is about. It's about the information. So we bias people by giving them true information from the rest of the show. We said, well, the thing is this woman, she was in a horrible relationship before, so she quite validly has trust issues. So that's why she's snooping on the phone. So yeah, give her a break because she's got out of this horrible thing. To bias towards the male character, we said, yes, he was doing flirty text messages, but actually earlier in the day, he told her, I'm sorry, I'm in love with this other person. There can't be anything between us. He was actually a good person about it. So again, give him a break, right? So we just nudge people towards sympathy of one character or another. Then we ask them, who do you agree with, who do you empathize with, and we measure their engagement. And again, just to steal the headline, don't really understand the results, but I'm going to try and tell you a story about them. Now, when we just asked people, who do you empathize with, who's in the right, what we found is if we bias you towards the female character with the information we told you, then you empathize with the female character. If we bias you towards the man, you empathize with the man who thought he was right. This is not surprising, this just means we were successfully changing people's interpretation of that scene. Not a big deal. We also said, well, forget about the bias. If you just happen to be male or female, how does it change? And this is just somehow depressing. People just walked into that scene, and if they're a man, they seem to agree with the man's position. If they're female, they agree with the female position. You didn't say anything to them, you just walk into the room immediately, yep, he's in the right. Kind of depressing, I found, but there you go. Again, that's our default thing, I suppose, is to agree with the people most similar to us, even on that course level. So that's just people's judgments afterwards. What about their engagement levels when we tracked how physiologically do they seem into this particular thing? And this is the bit I don't understand. Because now it gets different for if the participant is a man or a woman, and we get an interaction. So, if you look at just the men, overall they were less engaged in these scenes. By the way, I don't think these are interesting sex differences, really, and I'm not interested in man-female sex differences. This is just a difference we think of how much you're into this scene. The men tended to not be in this scene, not be engaged in the scene as much. And the bias information we gave them didn't really change that engagement, didn't go up or down, because they just care less about it, right? They'd rather watch something else, they don't like this video, they don't care about the information, about the texting, it doesn't matter. But when you look at the women, and you look at them specifically, we get a difference in the biasing condition, but it goes backwards. So they empathized more with the female character. They thought she was in the right, if they are female or if they're biased, but they were more engaged when they were biased towards the male perspective. Men just didn't care. So, I don't know what's going on here. It's quite a strong pattern in the data. This is my best explanation. Is in general, viewers report and experience agreement and empathy with people who are similar to them or they have more information about. And that makes sense, that's the first results I showed you. For people who are engaged less overall, which happen to be the men in this case, they didn't care about that biasing information because they just don't care. When you look at the women though, for people who are more engaged with this, in this drama, who happen to be female in this experiment, they found it most engaging when they were biased towards the person that they didn't necessarily engage with. So they might empathize with the woman more, but what they found dramatically more engaging was when they were shown the male perspective. Because that's drama. Drama is tension. So if you see the scene and you're already on the female side, it's less dramatic because, of course, she's in the right. But if I can nudge you towards having sympathy with the devil, right? If I can give you that other perspective, then that hooks in more and people are more engaged. So what we're really interested in is just exactly that notion that we can look at engagement, we can look at drama and shift where that perspective is. You have to care in the first place, but if you do care, you can then maximize that engagement by doing all of these techniques that playwrights and artists know about all the time. Pulling your expectations, subverting your expectations, pushing you in one direction against what you might want to believe in the first place. So this really sort of very biological, simple tool, we think might have this really exciting promise to try and unpick all of these interesting artistic things that people do with narrative and other things. I've come to the end of my time here, so I'm just going to, this final slide is to give me a sense of hubris. It's my warning against hubris. This is the Eurovision German entry. That's going to Noblik, winking at you. And why is it there right at the end? It's to remind me of my failures, because I've boasted about this tool and how you can tell you about engagement, how it can predict audience liking, and how it has this incredible power to all these things. I have also tried for 3 years running to predict the winner of the Eurovision Song Contest using these techniques. Because I figured if I could do that, if I could take the videos from the semi-final, predict the winner, be all over the newspapers, I could sell my tool for millions to Google and I would be famous because I cracked this thing. And I have failed dramatically 3 years running. So just because I have this tool that can unpick narrative and other things, it can't do some things. Eurovision is resistant to any scientific understanding. I have decided, I have given up, I'm never doing it again. But that's because it's an incredibly complicated, culturally ironic, weird thing with politics in the midst of all of these things. And sometimes you have to admit this phenomenon is just too complicated, as Eurovision is for me. You can't see them, but that's thanks to all the incredible undergraduates and students who have helped me. And thank you for your time.
Great. I'm thinking we should take maybe a few minutes of questions. So if I can ask all three to come in, we have sort of we just take a few minutes for questions that have come up that are burning. We have a bit of time before we go into the break. Yeah, so I'll just take this one. So, any questions from the audience, thoughts that have come up? Everyone's desperate for coffee, maybe. Bea has one. Yeah.
Daniel, this is maybe for you. It seems to me that your Eurovision attempt, it doesn't work because there are so many variables that you cannot control and that you cannot measure. But you can measure all of this all these very many variables in the laboratory as much as you can. What are the stronger challenges that you can see in a laboratory experiment when you try to unify, for example, when you have fans from a particular football team, they all have the property that they are Liverpool fans, but they also have many different personality traits and so on. Is there any other characteristic that you haven't talked about that you think is very important to bring into the picture?
Yes, we have. Oh, thank you. Yes, in all the experiments that we talked about, there is an enormous number of variables that are going to be affecting how engaged you are in the moment. And with football, yeah, there are complicated tribal allegiances that work on different levels, your dad's team, your team. Just in that tightly constrained thing, it's really complicated. This is his PhD, so he's going to be figuring this out at some point. Robin, sorry, who's interested in those levels of fandom and how they change and so on. So I don't have a very good answer to overall how we can quantify that. All we can do is pick on individual variables and try and shift them in the lab and see how they affect it. So you watch this football match, but then you watch a montage of you watching Liverpool matches as a child or something, where we turn the dial up. We have you stand up and sing the national anthem before a national match. So I've tried not to tackle all those questions head on. We've tried to isolate them individually, but there are a lot of them. But yeah, it's very hard because in the real world, all these things are mixing at the same time. So I can tell if a factor has an effect, but I'm not very good at saying which is the most important one, because it's very hard to measure and compare them against each other. But yes, it's a huge challenge.
Just a quick for Jamie, what's the engagement with the NEUROLIVE project on your? We saw a lot of the background work that you're doing, but what are you doing specifically here for the?
We need another talk for that. My understanding, my remit for this talk was like all the stuff on the side, but all of the 4 or more performances on NEUROLIVE have been involved with, like, how do we facilitate getting these sensors on people, getting all the EEG system synchronized that Jamie was talking about. We've tried, as an example, many attempts to try and get all these clocks to synchronize over the years. Early on, one of them, which I could have spoke a little bit about, was if you have... Was the idea of clock desynchronization quite clear to everyone? If you imagine, if everyone looks at their watch right now and look at the second hand and were to compare it, they would actually be off by a little bit. Clocks are notoriously not in sync, and we knew about this problem for years, and we're trying to, like, how do we do it, because all these devices are separate and we want to get millisecond level precision. Well, one thing we used was to put light sensors on them, little light diodes on the devices, and the theatre gives you this perfect opportunity to turn the lights off and on again. And we could use, light is instant, so ideally. So we could capture the light signal alongside the data and allow us to synchronize everything. So the clocks might be wrong, but you know that everything went dark at that point. So we tried a whole bunch of different things like that. So my involvement was in and out of that sort of stuff, trying to get those things working.
My question is for Jimmy Ford. And it's really, I'm curious about your artistic process to turn EEG data into a 1 minute, because that's a 60-minute EEG recording of multiple person that you turn into 1 minute music piece. So I'm very curious the process and your decision making behind that.
I feel like that needs to be a paper I should write, but I think it fits quite nicely into how I make art in general. Like, I always turn it into a problem or a research project. It has to be, there's some kind of thing that makes me want to get under the surface of making a piece of music. It's something interesting about structure, or something interesting about sound design or spatialization, or something that kind of gets me hooked in. And I find it's sort of stepping back being. What makes me creative is distracting my creative or anxiety of being an artist and what this means to make something and put it out there, and I can distract myself from more tangible problems, and then through that my process often leads to something. It's kind of a distraction. So, but specifically about the EEG thing, I suppose it was a lot of just getting to know the data and getting to know the systems and getting really familiar at all these different levels of things. And that's something I think is quite important in my practice. And I normally use the word computational artist these days for the kind of way that I work. And even if the output is sound or performance, I think very much about how I can use technology in that and really get inside the technology and understand what is going on. It's kind of an obsession, and sort of taking things apart and then putting them back together and thinking about things that I can see in the EEG signal, structures, patterns, dynamics that are in those kind of signals. How might they then translate to something that can be perceptible? And there's a whole different range of the ways that you could do that.
Just to follow up on that, because I was also thinking, I thought when you were explaining this minute that you showed us, that is sort of a summary from 60 minutes, right? Like 1 hour into 1 minute. And then you said like you're basically playing like average and standard deviation, right? The standard deviation was like how much variability it is, right? On the data. And that was pitch or something like that you said, no? And I thought like, is that just a very intuitive, like was the purpose of creating like a very intuitive way of just capturing the synchrony?
It was
like was that
the simplest thing I could
how
think
much
of,
pitch, yeah. And you already know in such a easy way, like it's going to be more or less synchrony in this
yeah. So
performance.
if you listen a few times, lots of the little percussive type sounds happen in clusters, and that does seem to be an indication of the synchrony in the 11 people that were in that. Obviously, we're squishing timescales massively, but it did seem that was a very crude measure of synchrony. So turning that into something distinctive sonically, I guess that was compositional. I wanted that to pop out. Like the background texture was, kind of more closely translating the waves into just rumbling kind of sounds like brains, whatever. But the plinky things were informational, I guess. Yeah.
Thank you. It's a question for Daniel. It's this collective experience. It's amazingly interesting, and I was wondering, the pandemic of this deprived of this collective. I was wondering, 5 years on, how do you observe where we are before and after? In relation, are we back or have we deviated somewhere else in relation to this collective?
Yes, that's a very good question. I think we're back for the peaks. So what I mean by that, we were at a conference a couple of years ago and someone did this great survey and just said, what's the top 5 things that have ever happened to you in your life, like your greatest hits of your life? And of the top 10, 8 of them are collective experiences. It's rarely, I was by myself and did that thing. It was the concert, the religious thing, my wedding, right? It's always a shared experience. So I think for that we're back. People have gone back to stadiums, they've gone back to live experience, they've gone back to theatre. All that's rebounded, and that's great. But where we've dropped off and might not come back is the day-to-day stuff. It's not going to the lecture because you can watch it at home on Zoom, but missing that collective thing of us, the students, together in this class. Or the same with offices. So but I don't know which is going to have the stronger effect, right? Are we going to be okay because we still got the peak stuff? Or is it really that day-to-day collective experience that's going to matter 10, 20 years' time?
I was also wondering, not only in terms of activities, but the effect on the consequence on the brain of this separation period, experiencing collectively separation, and what did it do to your brain?
Yeah, I think we don't know yet, and it's hard to measure and separate out from the death rates from COVID and other depressing things, right? But I think in general, that lack of that shared experience that technology has brought, right? We don't even watch TV programs at the same time because we stream them differently. When I was a kid, the Christmas TV shows were watched by 30, 40 million just in England, and you just don't get that. So I think there's a big shift in that what is the simultaneous shared experience. But I don't know if that's compensated by every kid has seen the same funny meme that week, right? This is the whole question in NeuroLive, right? How much is that, what is the important bit of a thing being collective for it to give us those benefits? And I don't know if you have a better answer than that about long-term differences. Fair enough. I thought I'd ask. But it's a very good question.